Hello, you are most welcome. I'm teacher Ivan from Wuna Educational Services. Today we shall be looking at the scientific notation and the significant figures. Let us start with scientific notation, or commonly known as the standard form. A number in standard form is written in the form of a times 10 power n, where a runs from 1 to less than 10, i.e. that is from 1 to 9. And n is an integer which can be a negative natural number or 0. So when do we use the standard form or the scientific notation, and why? Scientific notation is used for writing down very large and very small measurements. For instance, if I have 69,750,000, this is a very large figure for me. So I can decide to write this in standard form or scientific notation. That is, I'll say 69,750,000. This one has no point, so I can introduce a point at the end. Then I'll move to the left until I leave one digit to the left, and that digit should be from 1 to 9. It shouldn't be less than 1, it shouldn't be more than 9. So I'll move my decimal point. As I move, I count the steps because it gives me the power. So that is 1, 2, 3, 4, 5, 6, 7. So this is 6.975. I can ignore the zeros. Times 10 to power 7. And this will be my number in standard form. Or I can also express, this is a very small number which can also be written in standard form. That is, I have 0.0001250. So I'll move my decimal point towards the right, but this time I'll move to the right until I come up with a number that is more than 0. That is 1, 2, 3, 4. And you must leave only one digit to the left of the point. Because remember, that number has to be from 1 to 9. So if I move to the next step, my number will be greater than 9. And it disobeys the law or the principle. So you must always leave one digit on the left of the decimal point. And that figure should be from 1 to 9. Hence, my steps traveled are 1, 2, 3, 4. So that becomes 1.25. I can ignore the 0 because the trailing 0 after a decimal is useless. So I would have 1.25 times 10 power negative 4. So what do we notice from these two examples we have done so far? In the first example, I was moving from right to the left and my power was positive. In the second example, I'm moving from left to right and my power is negative. And that observation draws a conclusion for us. When I'm moving my decimal point to the left, the power will be a positive. If I'm moving the decimal point to the right, the power will be a negative. After making that conclusion, let us continue. In our example 3, we have 60,025.75. So I have a point, but I have to move this point until I get one digit on its left, and that digit should be from 1 to 9. So since I have 4 digits on the left, I have to move the point until it is 1 digit. So I have 6025.75. So I'll move my point to the left. That is 1, 2, 3. So I move it 3 steps to the left. Why? I had to leave one figure to the left of the point. So I come up with 6.02575. Since I've been moving to the left, therefore my power is positive. And I've moved 1, 2, 3 steps. So that will be times 10 power 3. Let us continue. In our fourth example, we have 12.250. So since there are 2 digits on the left of the decimal point, therefore I'll move 1 step so that I remain with 1 digit on the left. That is, I have 12.250. So I move 1 step so that I remain with 1.225 times 10 power 1. Similarly, in my fifth example, I have 2020 with no point. If you have a figure with no point, create the point at the end of it and move that point until you get one figure on the left. That is 1, 2, 3. So I have moved 3 steps to the left. So that gives me 2.02 times 10 to power 3. I'm ignoring the last 0 because the ending zeros after a decimal point are of no use. So I end up with the 2.02 exponent 3 or times 10 power 3. I'll leave number 6 for you to try out. Otherwise, we have times 10 power n. We read this as, if I have a times 10 power n, I read this as a exponent, then exponent n. And when you check on the calculator, we have that exponent button. It is always on the bottom line of the buttons on your calculator, and it is always written as exp, meaning exponent. So you can just say, for instance, if we have 2.02 times 10 power 3, this is the same as saying 2.02 exponent 3. So exponent means times 10 power. Otherwise, that has been how we change digits or numbers to standard form. Please don't forget to subscribe and hit the notification button so that whenever we have a new video, you get notified. Otherwise, I'm Teacher Ivan from Wuna Educational Services, where we make your learning convenient. Thank you. We meet next time when we are looking at the significant figures.